Hello again. We are now going to get into example 2 from section 12.3. So it's just another example, but it's a little less guided in how we get through the process. So we have another set of data. We got 1, 2, 3, 4, 5, 6, 7, 8 values in this data set. And so we do want to find that sample standard deviation again. And this should have been on the next page. So don't worry about that. Okay, so what's step number 1 of our 6-step process? Hopefully you remember it, but step 1, remember, is to find that mean. So we need x bar. So we have to add up those numbers and divide by how many we got, which we know is 8. So let's add those up real quick. So we got 2 plus 5 plus 6 plus 8 plus 9 plus 11 plus 15 plus 19 equals 75. So we got 75 over 8. Let's divide that by 8. 9.375. Now, if you remember the previous problem, we had to square numbers and things like that. Now, the one weird anomaly, but it's not too weird, is when you square something that has decimal points, it actually doubles the number. So if we kept all 3 decimal points, we're going to end up with 6 digits, 6 decimal places, which is way too many to work with. So let's round this a little bit to 9.4. 1 decimal place is a little bit easier to work with. So 9.4. So if we use that to go to the next step, which is we have to subtract. So x minus x bar. Now, if you're struggling to remember the steps, let me just take a quick second to write out those steps. So, and maybe I'll just write them on the side over here. So remember, step 1 is the mean. Step 1 is the mean. Step 2 is to subtract. Step 3 is to square. Let's make that look like a 3. Step 4 is to add. Step 5 is divide. And step 6 is to square root. So now we have our 6 steps. Just quickly summarize so that way we can go through this a little bit faster. All right, so now we have our mean, and so we're at step 2, we want to subtract. So 2 minus 9.4, and so that will give you a negative. So negative 7.4. 5 from that, negative 4.4, negative 3.4, negative 1.4, negative 0.4. And so now we have numbers that are bigger, so we should get positive answers. So 1.6, and then we get 5.6, and then we get 9.6. All right, so there's step 2. So step 3, we have to square those results. And again, no negatives. So x minus x bar squared. All right, now, because I don't want to mess this up, let's make sure we do it right. So 7.4 squared, 54.76. 4.4. Now you can see I'm not putting the negative in there because I know it should be positive, so I might as well not even put it in. 1936. 3.4. 1156. 1.4, I can do that one. 0.4, I can do that one. 1.6. Let's make sure I get these last 2 right. 5.6 squared is 31.36. And 9.6 squared, 92.16. Okay, a lot of steps to these standard deviation problems, but you know, once you are beyond this course, eventually you start to use technology more and more, and you can do these calculations much, much faster. But for now, if you're just learning it, unfortunately, it does take a little bit of time. So, but we are at step 4, which is to add. So we want to get all those added up. So let's add up those squared numbers. 54.76 plus 19.36, 11.56, 1.96, 0.16, 2.56, 31.36, and 92.16. So 213.88. So that's step 4. So I like to write the little preface here, but again, it's not absolutely necessary as if you're following through the process, but to show your work, this is always a nice way to do that. All right, 2 more steps. 5 is divide. 5 is divide. Oops. So in this case, we have our sum, 213.88, over n minus 1. So remember, n was 8, so n minus 1 better be 7. So let's divide that by 7. And you can see I just left the calculator alone. I left those results in there because typically you can use it for the next step. So don't clear it every time you do a calculation. Leave it in there until you know you're not going to need it. So 30.55428.571 and so on. Now, again, you might be tempted to round this. I wouldn't round this yet. Rounding should only be saved until the last step. If you do a lot of rounding throughout the problem, then you're going to cause potentially a lot of round off errors. Now, yes, we did round here, and that could potentially impact it, but we're just trying to make the calculations a little easier by rounding initially. But throughout the problem, you really don't want to round. So I'm going to take the square root of this for step 6. And because I didn't clear it out of my calculator, it's still there. All I have to do is hit the square root button, and I'm done. So 5.5275932121 and so on. And if we want to round this, again, 1 decimal point is really all you need because your data were all whole numbers. So 1 decimal place is good, but I personally like 2 decimal places just to give you a little bit extra accuracy. So if we round it to 2 places, we would put 5.53. But remember, 5.5 would be fine. So, all right, well, that wraps up that problem. So now we will see in the next video how we can apply this to a frequency distribution. So it's a little bit more, but it's a lot of the same steps. So we'll hopefully see you in just a minute.